Today we will discuss about indexing, slicing and appending in Scilab. Indexing, each element in a matrix is characterized by two numbers, row number and column number. These numbers are used to pinpoint an element and operate on that. These are called, this row number and column number, these are called index and index of elements. Index of elements. Okay. For example, if we generate a matrix, any random matrix like A, rand 3, 4. This rand function, if you want to know about this function, you can watch my previous videos on that. If you generate the random matrix of 3 cross 4, and then if you want to know the element and the position 2 comma 1, this is the indexing. For example, this means element of second row and column first. This first number indicates row number and this second number indicates column number. When you type this on the Scilab main console, you will get the answer, the element at this position. This is known as indexing. In Scilab, you must know that in Scilab, indices starts from 1 and indices start from 1. Okay, and it does not take negative numbers. It does not take negative numbers as indices. Okay, we can also use this indices to make a new vector. Okay, we can also use indices to make a new vector. For example, I will show this in the main console in the Scilab. We are going to see this in the main console. Here, for example, if we generate any random matrix, for example R A N D rand 3 comma 4, here we have generated random matrix. Now if you want to know the element at the position 2 comma 1, let the matrix be denoted by the name A. We write, we generate an element rand A equal to rand 3 comma 4. Okay, enter. Then if you want to know the element at the position 2 comma 1, this position, here you get the value 0. Here you get the value 0.198 at position 2, no, row number 2 and column number 1, this number. Similarly, we can also use this indices to make a new vector. Suppose we have this vector. Suppose we have this vector A, where we generate another vector B equal to suppose B, we generate this vector B equal to any random vector first. Suppose 1 1 4 2 2 4 5 6 7 8 9 0 5 7. We have generated this random vector. Suppose now here we will generate a new vector from this vector. What we will do, we will use this command c equal to the name of the previous vector from which we have to generate a new vector b. C equal to b parenthesis, okay, and this long bracket. Suppose we write 2 comma 4 2 4, okay, this, close this, and we get the elements 4 2 4 2. Why we get these elements? Because at position 2 we have this 4, and at position 4 1 2 3 4 we have 2. We get 2 2 4 2 4. That means second element at and fourth element of this vector, of this previous vector, we have generated another vector 4 2 4 2. In this way we can generate, or we can make a new vector from this using this indices. Okay, same method can be applied for two-dimensional or higher dimensional matrices. Okay, now we will discuss another concept in the Scilab known as slicing. Okay, in what we will discuss in the slicing, matrices can be sliced to desired portions by using indices and colon operator. Here in slicing we use this colon operator and indices in slicing. Okay, now we will discuss this in the main Scilab console. Suppose you have a matrix. First of all, we will clear this main console. CLC. Suppose A will generate a matrix A equal to 1 comma 2 comma 3 colon 4 5 6 4 comma 4 comma 5 comma 6. Here we have just generated this matrix of the order number of row 2 cross 3. Now there will be another matrix B equal to, we write this matrix in this way, 1 is to 3, okay, 4 is to 6 colon semicolon 7 is to 9. Okay, close bracket. Here this is another matrix of order 3 cross 3. Now we will generate the analytic matrix C, which is equal to A matrix B matrix A colon this matrix B. This is known as slicing. Okay, the horizontal concatenation can be easily performed in the following way. Suppose you have matrix. First of all, we'll clear this console. Suppose A equal to 1 raised to 3. Okay, B equal to A comma A. Here in this way we can concatenate, we can make horizontal concatenation in this way. This is known as slicing in Scilab. Now there is another concept in Scilab known as appending of row and columns. Here the size of the new in appending, the size of a new matrix must be taken into consideration while appending an entire row or column of a matrix. Suppose you have matrix A equal to 4 comma 5 4 comma 5 6 comma 7. Okay, enter. This has 2 cross 2 matrix. Now B equal to in this here we will say it will be 4 comma 1. Hit enter. This is number of rows 1 and number of columns 2. 1 cross 2. Now the size of matrix A. If you want to know the size of matrix A, size A, it is 2 cross 2 and size B, it's 1 cross 2. Now we will generate a matrix C which is equal to A, B, here this matrix is 3 cross 2. In matrix C, what we have done is the first 2 rows 4, 5, 6, 7 are from the matrix A, and the third row 4 comma 1 is from the matrix B. In this way we can append the rows or columns of a matrix. You can generate, for example, matrix D. Let matrix D equal to for example let it be 3 of 7. Enter this, and matrix E equal to, you can write it as A D, A D. It is inconstant row column dimensions. We cannot perform this option. Instead we can perform this one, A comma D. That's why at the first I told you that you must the size of a new matrix must be taken into consideration while appending an entire row or column of a matrix. Here this way you can perform this. The matrix A, what we have done, we have appended, actually we have added another column 4, 5, 6, 7. It was the matrix A, and we have added another column 3, 7 from this matrix D, because D in D matrix we have generated a number of rows 2 cross 1, 3, 7, and we have added that column to this matrix. In this way we can add a column or we can add a row, so like in this way in the C matrix A, B, we have added another row 4, 1 as you have seen. Okay, thank you. This was a short video about appending, slicing and indexing. Thank you.